Thanks, folks, for joining us this afternoon. We're going to walk through the topic of the cloud optimized data lake and what that means and what that may mean to your organization. For planning purposes, we're going to go over several topics. I expect the time to run about 20 to 30 minutes, and then maybe a 10-minute wrap up with Q&A. I do expect we'll get several questions based on the topics. But for your information, what we'll be discussing today is we'll do a level set based on terminology and definitions, and we'll get into some in-depth definitions with regard to this topic. We'll also walk through some common misunderstandings and give an understanding of what that may mean to you. And we have an interesting point of discussion as well, which is going to be where is your data, which has some interesting points to it. And then the last two topics are going to really revolve around how you start, how you get there, and how you can actually realize the full potential of an optimized data lake. And again, what that may mean to your organization. So the goal of today's session really is to walk through what we've seen from our company, from our customers, with regards to cloud and how they're being utilized in the data lake and data marketplace space. As well as we're going to weave in some of the Podium specific, cloud-specific features and how that actually enables this optimized data lake concept. So let's start with terminology and definitions. So Podium actually sees several different definitions with regards to cloud, and one is probably what people think of most often when they think of cloud implementation, and that's what's called a full cloud implementation. The idea there is the standard data lake architecture, and we're going to talk a little bit about data lake architecture later on, is fully deployed on the cloud, and really it closely mimics what you may already have or are thinking about have from an on-prem structure and implementation perspective. But the core components of that, the compute, the storage, the Podium components, if that's part of the discussion, are actually housed and executed and installed on the cloud. Now, typically, this does have an exception, and the exception really revolves around what might be considered external security components as well as data components. So, the obvious data components there is that you may have data sources that you're onboarding into your data lake that most likely are going to be on-premise. Of course, you may have third-party data sources that may or may not be in the cloud. But the idea, our definition of full cloud really is all the core storage, processing components, server components are in fact not on your premises, but are hosted by a cloud provider with those noted exceptions, which we will talk about quite a bit in a few minutes. So here is a very simple visual example of a full cloud implementation where basically everything in the blue, except the notes the exceptions I'm going to make in a minute, are actually housed with a cloud provider. From a data cluster perspective, this also includes the compute portions of the solution as well as security and storage. And as you can see, we also have seen the data sources being on-prem or in the cloud, and there's some virtual private security that will be surrounded by that. And again, we'll dive into that a little bit deeper when we talk about some of the terminology related to that. Another couple of important points when you're considering the full cloud definition, that things like the definition of your internal users and groups within your organization can directly be integrated with Active Directory as well as other security components. So again, that's one of the quote-unquote exceptions to everything being on the cloud in the full cloud definition. So moving to the next definition, this one seems to be gaining in popularity with regards to what we're seeing in the marketplace, and that is the concept of a hybrid cloud implementation. So a hybrid cloud implementation really is probably what you're thinking. There is a mix of components that are actually installed, managed, and running on-prem and other components would be in the cloud. And we're going to talk about some examples of what we see as typical hybrid and why they seem to be gaining in popularity. So hybrid variation number one, and this is a very interesting variation, is there is this notion of a gateway on premise. And that gateway can be a kind of management server like Podium, where it's installed on-prem. All of your network security firewall settings are actually geared towards this gateway rather than to every hole, I'll say it this way, every hole you have to punch from your source data systems or applications out to the cloud. This gateway being on premise has some advantages, again, we'll talk about in a little bit, but this really allows a data lake with sensitive metadata and some maybe core operational tables to be protected behind the firewall while orchestrating the compute operations as well as the management of the data from a storage perspective in the cloud. And this is a very common, popular variation of hybrid. Hybrid variation number two, or hybrid approach number two that we see, is that you could actually have the concept of a sensitive data lake on premises, and maybe that's a smaller quote-unquote cluster, and you have a much more widely available data set that's not as sensitive. That cluster and the compute and the storage is in fact on the cloud. And in this scenario, that concept of a gateway in approach number one can actually apply to either or both of the sensitive data lake or the kind of open data lake that may be on the cloud. So in this example, the hybrid approach number one, from a visual perspective, you can see, in fact, this is what we talked about earlier, where you may have your catalog node or your gateway node. You can call it really whatever you'd like. In this case, of course, it's a Podium install, which essentially, and again, whether it's Podium or some other metadata manager, it is essentially a web-based application that is sitting on-prem, and that really allows you to a finer level of granularity in management from a user perspective and a security perspective. And some real examples are, we've actually have customers that do have a full cloud implementation, and every time they bring in a new data source to their data lake on the cloud, they have to go through the network security team to open up certain ports on their internal firewall such that data can pass through it. Now, while that's not a major technical hurdle, sometimes it takes a week or two to actually get that through the network process. In this hybrid approach number one, that bottleneck of getting data to your users goes away because the Podium node itself has its own connection directly to the customer and is managing the cluster, the compute, and the storage. So you actually have a single point of gateway there, which is a really nice approach. Again, this is what we see probably is the most common approach in all of our cloud implementations and experience. And again, hybrid approach number two, now that we do in fact have a visual here, really shows the concept of clusters being on-prem and within the cloud, depending upon your security need, performance need, or cost need. So that's kind of the visual. So there are some important definitions when we're talking about an optimized data lake, optimizing your data lake on the cloud, and it's really important to get beyond the obvious definitions here and what they actually mean. So we're going to talk about compute, storage, including the notion of cost-based storage and what that actually means, as well as the importance of a catalog and what a catalog may mean to the success, as well as elastic, and again, how that plays into this. So some of the obvious terms here, compute, right? So compute, when you hear compute referred to within the cloud definition, it really refers to the notion of configuring CPU and memory resources such that they're provisioned to execute computer programs. Simple as that, right? Those are your compute cycles, and there's an important distinction there. Storage, which really can be, amounts to disk space, can be virtual or physical. And again, it's used to not just store data, which is the obvious, but programs and other system artifacts. And again, we'll dive a little bit deeper into that. So one thing that has been, kind of buzzing around, mainly due to the cloud providers, creating and pushing this concept of low cost storage for, maybe high latency or not so fast requirements access to the data. So you hear a lot of buzz about this low cost storage, Amazon's Glacier and things like that. But what's important to understand with the optimized data lake is how that actually fits into your picture and your architecture. And we do find there's a real good value proposition to be kind of garnered from that notion of low cost storage as well as high performance storage. So one term you may not have heard of, because it seems to get often overlooked, and we believe and have proven that the concept of a catalog really becomes the core linchpin of succeeding, not just in succeeding in implementation, but succeeding in being able to be nimble in your cloud approach. And that's the concept of a metadata catalog, where most people think of the cloud as a place to put their data, but being able to actually manage all of your data objects from a metadata catalog, and this includes the life cycle of that data, from moving the data to the cloud, from using the data, and maybe even publishing the data back off of the cloud, and executing that within the lake. You'll see in a few minutes why that becomes a really critical and core component of a successful cloud-based data lake. So keep that in mind, that the notion of catalog, because that's going to play a pretty big theme going forward. So elastic, again, a very common term that you've heard. So kind of the industry definition of elastic is really the ability of a system, right? And the system in a lot of cases, but really cloud provider dependent, really refers to the compute side of things, while certainly storage can be elastic, but it really in most cases refers to the compute, where you can dynamically resize your compute resources based on computing needs at any given time, right? So this is certainly one of the major value propositions within being able to optimize your cloud. And optimization is not just performance, but it's also effectiveness of delivering data and, of course, cost. So you can imagine that you have data that at any given time of the day or any given time of a quarter or even an annual cycle, you have much higher compute capacity requirements that you don't want to pay for those capacity requirements when you don't need them, right? So that's the simple premise of Elastic, that at that time, you are dynamically resizing your cluster up for being able to handle these what we call peak computing needs. You pay for it when you use it, but when you dynamically scale that back down, you're only, again, paying for the smaller portion of that. So that is an important part of this. Now, there is one key factor in Elastic as well, and that is, how do you manage that? How do you know when you actually need to cycle things up and cycle things down from a usage perspective? One last point I wanted to make on the terminology and definitions, and that is really one of the key benefits of the cloud is what we like to call the easy or transparent separation of compute and storage. And this is really what drives one of the major cost benefits along with Elastic. So in other words, you can have your data sitting on some storage in the cloud, but you're not necessarily firing up your compute cycles until you need them. Now, imagine the benefit of having a detailed catalog of that data. Again, that is from a podium perspective is a fairly simple web application that has done a tremendous amount of cataloging of your data. So the users actually have access to the catalog. They actually have access to see certain parts of the data, and you haven't actually had to fire up a set of compute cycles, which in fact is about the most cost intensive part of the cloud. So that is really one key advantage there that we wanted to get across. And again, we'll drill on that a little bit more when we talk about some of the details of implementation. So some of the common misunderstandings that we've seen over the last year, some of these change very quickly, but really in discussion with some folks. So there's a common misunderstanding that it's all or nothing. So once I move to the cloud, I have to put everything there in order for it to be efficient, in order for it to be effective. And that certainly is not true. Based on the hybrid conversation, you can see that really you can bifurcate your data according to your needs. And it is not an all or nothing. And in fact, I think it's a far more effective approach to choose your applications and your data that are going to move to this cloud optimized data lake infrastructure wisely. So one of this second bullet is an interesting one to us, because this certainly has, this concern has waned over the last couple of years, but the fact that your data may be in the cloud and it's not secure, as well as just some other common perceived risks. Not only is it not secure, but other folks can actually look at my data, my cloud providers. Our experience is actually quite the opposite. All of the cloud providers have a tremendous level of security, not only wrapped around the data, the storage, but also the virtual private clouds and the security that comes with it. So this certainly has been a major concern, but we find this concern actually dropping as people, really are finding out that this has really been addressed very well. Another misunderstanding, and this is an interesting one that I want to talk about for a minute, is that it's really cheap or really inexpensive. And again, what we find is you have to define what the cost of ownership is to define what's expensive or what's not expensive, right? So I like to put it this way. If you go and look at a certain size cluster and you're paying for that cluster on the cloud, and after a year you add up all the math and you realize that, gee, after a year, I could have owned that hardware. Maybe like leasing a car, I could have owned that car. That's not really a fair comparison. Now, you'll find out that at first blush, boy, that doesn't seem really cheap. But then when you factor in the total cost of ownership, the uptime requirements, the backup, the recovery, all of that stuff, the total cost of ownership becomes quite compelling. But the point here is, when you get the bill from the cloud provider, it's usually not as cheap as you think it is. And again, you have to really take a much more holistic view of that total cost of ownership as you get there. The other one is, and this is an interesting one. If I choose one cloud provider, I'm locked in and I'm beholden to them. This is actually not true at all. And in fact, if your data lake infrastructure is implemented, what we consider in a best practice way, not only are you not locked into a cloud provider, it's extremely easy to switch cloud providers. And that gives you as an organization a tremendous amount of leverage, from a price negotiation perspective, and again, the ability to not only move from cloud provider to cloud provider, but even moving from on-prem to cloud or cloud back to on-prem. And we're going to talk about that a little bit more and why that's really, really important. And then the other kind of notion, and this is really where people get hung up, is it's really going to take me a long time to make that switch from on-prem to cloud, or make that switch from one cloud provider to another cloud provider. Again, similarly to the point above, if you've implemented certain key aspects of your data lake, this actually becomes pretty easy to do. All right, great. And again, thank you everybody for your patience there as we got our pictures up. So this is a key question when considering your data lake in the cloud, right? And that is understanding where your data is and how it's stored and how can it be accessed, right? So again, this concept of storage with no inherent directly attached compute cycles, there's a lot of good to that from a cost perspective and a growth perspective. But can I access my data in that environment do I have to spin up a cluster every time and things like that? So the truth of the matter is there are limited tools provided by the cloud providers that allow you, and when I say limited, other than development tools, right? So you're not going to, dive into writing glue or, within the Lambda architecture, but other than development tools and Excel-like viewers, there's not a lot of ways to kind of get in there and manipulate that data unless you start, spinning up clusters. And in order for that to work, transparency to this is crucial, right? So the data consumers who are actually ultimately driving the value for your organization, they don't really care where the data is or how it's accessed, just as long as they can access it, it's available, and they know what's there. We're going to talk about how to solve that problem. So look at low-cost storage. Again, we believe it's a great concept, and we think it needs to fit into an optimized data lake architecture. And we know it's cheap, but is it really going to perform for me, or is it just too slow? And it really boils down to your data, your data service level agreements. When do you need access to data, and how fast can that be? And in our experience, the right answer here is most likely you will have a mix of this type of storage. You will have some archived low-cost storage that will house your kind of least access data, and you have to define what that means, right? What is your least access data? And your configuration will very likely include high-cost, high-speed storage and low-cost, high-latency storage. But you know what? There is an interesting thought here. Well, what if I actually want to leave my data on the source until I need it, right? So if you look at your data lake in the cloud and your users have access to that data lake, and they actually can see that certain data is available to them and it's transparent to them, but the data itself is actually sitting in the source, we believe this is a game-changing concept, right? So now not only are you not paying for compute until you need it, you're actually not paying for storage until you need it. And really, just think of this as on-demand for the cloud. That's really what this is. And again, we're going to talk about that a little bit more in our last few slides, but these concepts are extremely, extremely important. So ultimately, the best mix for all of this is really a combination of cold storage, a combination of high performance, and a combination of on-demand. We believe the three aspects of this storage concept, including on-demand, is really where you're going to optimize your cost and optimize your performance on the data lake. All right, so let's talk about where is your data with regards to on-demand. So what makes this work, again, in a cloud environment or in an on-prem environment, is that if a user has to go out and find their data in the data lake, that data is fully cataloged. Our definition of cataloging that data includes a level of profiling, and a level of profiling and statistics that give the users a business-ready view of that data and understanding of that data without really having to do anything other than browse, right? So that's kind of how you should think of that. And the data is not only profiled, but there's a level of validation so they know the data is good. Those equal data that is ready. Now, the data producers, those who are actually responsible for getting data onto the lake, well, they can ultimately decide from an architecture perspective what goes in the lake, what stays outside the lake, and really gets what we call loosely coupled to the lake. Now, again, the key here is that the consumer doesn't know the difference, right? For them, the data looks all local, but in fact, it could be in very different places. So we have three levels conceptually of data within the Podium optimized cloud lake, and that is this concept of managed data. And this is what you would traditionally think about. I connect to a source, I bring my data on. That data is local on your lake, and it is available for consumption. We also have the concept of registered data, where you can actually point to a source. You can do all the validation and profiling, but you're doing it in an ephemeral basis where it's basically done in memory and the data is not landed, but all of that profiling and catalog information is in fact stored in that web browser, right? In that metadata, if you will. So that data, from a user perspective, looks no different than the managed data. And then finally, there's even a lighter version of this, and that's addressing the data. Addressing the data is you're connecting to your source catalog, but you're actually not even profiling or validating the data. You're just making it known that there is a source of data out there that have some certain characteristics. And again, those characteristics are really garnered from the source metadata itself, not the source data. So again, this concept of being able to catalog and have this data on demand, and that on demand, again, could be your data in your source that's on-prem, but your data lake has been deployed in the cloud. So think about the power of that concept. All right, couple more slides, folks. Thanks for bearing with me. Where do I start and how do I get there, right? Again, this at the end of every meeting we have, this is kind of the question that gets there. And there's really two ways to look at this. One is, are you starting from scratch? Which, interestingly enough, fewer and fewer people are today. Or are you actually going to migrate your existing lake out into a cloud infrastructure? Okay, similar answers, but different. So let's talk about starting from scratch. So, very simple things here. Identify the cloud provider. Pros and cons of each. We're not going to dive into that. These are well-known things that can easily be investigated and determined. Probably the most important first step is creating, vetting, and understanding what that data lake, data architecture looks like in all of their requirements. And again, this is something that Podium has been a leader in for at this point about 4 years. And for us, there is a really good set of best practice data architectures that should be implemented. And then really, finally, you're sizing the cluster, you're spinning up the initial system, and you're onboarding that data. Now, just to give a sense of timeline, and part of this is it's important to understand what each of these means, but we see a lot of custom-built lakes, custom-built from the ground up, and really from thought to users consuming their first bytes of data, typically is about 6 months, sometimes a little bit more, trying to be realistic there. Tool-enabled, where you have ETL-like tools that you have to build flows, we see that as kind of a minimum typical of 3 months. And the way Podium has built its crucial onboarding, again, this is not really embellishment here, but it's about a week before you're going to be able to see data and have users consume the data. And those are the orders of magnitude that we see. Similarly, from the migration of a data lake, all the same steps, except that last step is the migration of the data. Now, I want to talk about that for a minute because this is going back to the catalog concept that we talked about with regards to the hybrid data lake. In a Podium managed data lake, everything that has happened and everything that will happen is all driven from metadata. So if you happened to have a Podium managed lake on-prem, migrating that to the cluster really is a matter of configuration changes within telling Podium which cluster to talk to. Now, there is a physical act of migrating the data, of course, but if that's a purely metadata-driven process, it's really a turn the crank type of thing. Now, we have been involved in seeing custom-built migrations that do not have a full catalog set of data. And again, typically we see a minimum of about 4 months to get all of the data that you have in your production on-prem lake out into the cloud. And if you have a tool-enabled lake, that's certainly much cleaner because usually you're redirecting those tool flows to a new target, and that's a couple of months. And then again, we have actually done cloud migrations over a weekend, on the order of hundreds of terabytes to give you kind of a frame there. But typically we see that migration taking about a week, again, very similar. So some of the keys as you're thinking about getting started, as you're thinking about the value of optimizing a data lake in the cloud, is that as you onboard your data, it really has to be ready for the business, right? So this is not copying a file into an S3 bucket on Amazon and you have a data lake, right? That's not what this is, right? This is really, really cataloging that data such that they understand it and it is what we call business ready. And all of your data must be easy to navigate and find and use. So ultimately, a successful data lake is going to have hundreds to thousands to tens of thousands of what we call entities or files or objects, and they must be cataloged. And this really all must be driven from the concept that metadata really is a first-class citizen in this cloud-optimized data lake. And metadata, in our definition, includes not just technical metadata, but also governing with business metadata. So realizing the full potential here. So this is pretty much the last slide. I got a slide and a half to go through here. So what you want to be able to do is, understand where the risks are, right? So very quickly through this slide, there are significant risk factors in lakes. Again, from a cloud perspective, these are usually amplified, but there are security risks. Understanding the quality and meaning of the data is a significant risk. Again, this is a Gartner slide, so they get credit for this. Organizing that data becomes critical. Governing the data becomes critical. And realizing that full potential, all of these aspects actually must be addressed, okay? And finally, being able to actually understand your different zones and govern those zones within the data lake architecture on the cloud become critical as well. So we have, Podium's 5 tenets here that drive a lot of this optimization are this concept of data readiness that we talked about a lot, and the ability to get that data to market quickly, right? Minutes and hours, not weeks and months. Being able to secure that data as well as who has access to the data, being able to understand how you manage your history in the lake, especially in the cloud, because if you're not managing your history correctly, costs can get out of control. Being able to turn this into a lights out operation, and then providing self-service to those consumers who need it. So that's, again, a lot of words there, and we're going to kind of take a pause, and I'm going to hand this over to Barbara to see if any questions came in during the last 40 minutes.
Thank you, Bob. That is a lot of content, and but I think very helpful. There are a few questions that have come in, but if the audience wants to also put additional questions into the questions window, we will queue them up and get to them. The first one, Bob, has to do with S3 and AWS, and the question is, how does Podium work with S3, data in S3?
Okay, so great question, and by the way, I'll expand the question a little bit. It could be Azure's data lake storage, their DLS, right? So the concept of these kind of blob storage techniques or buckets. From a Podium perspective, we have a clear separation between compute and storage as well. So S3 to Podium, because Podium is actually accessing and processing from a storage perspective with all standard APIs. Podium doesn't see the data differently in S3, any different than if it was sitting in a homegrown HDFS, with Cloudera or some of the distributions. So from a Podium perspective, it is a configuration switch, and it becomes transparent to the user. And then one final comment on that, it's transparent to the user in 2 ways: onboarding the data as well as publishing the data. So if you want to actually take data out of your lake or out of your hot disk and publish it out to an S3 bucket, again, that's a supported kind of Podium flow.
Okay. Another question has to do with performance. Like, what are the performance implications of a cloud-based data lake? Yeah,
so this is a tough question, and I usually like to answer this question the following way. Performance is always governed by the slowest point in your process, right? So a real example of that is, let's say I have to do a nightly load of some data from an RDBMS that is on-prem, right? A very common thing in your data lake. So the performance, 9 out of 10 times in this example, is going to be bottlenecked or governed. I'll use a little bit more of a positive term, governed by the network performance, right? So once the data is localized to the cluster, our experience is the performance is extremely scalable and extremely linear. But it's really once you're moving that data, onto the platform that you have to understand the bottlenecks, or off the platform where you have to understand the bottlenecks.
Okay. And another question is, does Podium work with transient clusters?
So okay, by transient clusters, I'm assuming we mean clusters that come and go. I guess the definition of transient. So Podium, one of the key advantages with Podium is, if you think back to the conversation about the catalog, Podium has cataloged all that data. Podium's catalog is available to users to access. But if users actually want to do something like aggregate their data and join their data, that can happen really on any cluster. So Podium can actually work with dynamically spinning up a cluster at the time it is needed versus having a cluster up all the time to access the data. So that is actually one of the tremendous value adds. And again, that goes hand in hand with really the Elastic conversation we had earlier.
Okay. Another question here, how can Podium help me address data security if I've deployed my lake in a cloud?
So data security, we did not talk about that. I did a lot of kind of shilling for Podium in this presentation, and one of the things I did not do is one of the things we do best, which is apply data security. Podium applies data security at a couple of levels. One is we actually support field level encryption and obfuscation on the way in and on the way out. But we also secure data by tying data to security groups and user to security groups. So we have a data user and group model that is applied in the cloud, and we can apply physical security at a field level to the data. Did not talk about that, so great question.
And Bob, when we send, or for everybody on the call, when we send around some follow-up materials, I will include in that note some links on some of these supporting points, the data connector, the idea of registered address managed data, some of the stuff about security. So if you want to go deeper on those topics, I'll give you some specific pointers on where to get that information. Okay, and there's one more question which I think we might have covered, but maybe we can repeat it, which is how about migration, starting with an on-prem cloud lake and then moving into the cloud.
So if we go to a customer and they already have a data lake, basically what Podium does, and I'm going to answer this question from a Podium specific perspective, so the person who asked it may not have intended that, but what Podium does is we actually go in and we have this notion of cataloging an existing lake. So this catalog that I keep talking about, which is again the metadata driven approach to the data, Podium would go in, catalog all of your objects on your lake, and that's the starting point for migration. Because once that catalog is repointed to the cloud, it becomes a two-step process. One is redirecting your sources that are populating that cloud, through Podium for the ingest or onboarding, and then the second one, of course, is the migration of that historical data you have in the data lake, which we typically do with standard tools like distributed copy or more of a brute force method. But our first step is actually leveraging that catalog.
All right, and I think that's our last question. I want to thank Bob again and all of you for participating today. Again, we are recording this, and I'll send the recording around along with some notes tomorrow to everybody on the call. And I will include in that Bob's contact details. And if it's something you'd like to discuss further or dig deeper into, I'm sure he'd be happy to, maintain the conversation. So with that, thank you very much, and I am ending today's webinar.